Hello and welcome to Introduction to Poker Lecture 3. We again had problems getting the course capture thing to start working in the room that we have course capture availability, so we should start that soon. I will remind you, I am also not in a dark cave. I have something wrong with my webcam brightness where no matter what, no matter how many lights are on and windows open, it looks like I'm in a cave. I promise I'm not. So, Lecture 3, pot odds and the rule of 4. So quick review from lectures 1 and 2. Key concept is going to be important for today, and was also important for when we were discussing starting hand strength, because that's what we were doing in lecture 2, are implied odds and reverse implied odds. We're going to see these all semester. Saying them out loud. Implied odds is a situation where we stand to win more money if we make a strong hand. And reverse implied odds are the opposite, the situations where we stand to lose money when we make a hand. So implied odds would be there's a bad player who calls too much, they're attached to their pair, and we're on a flush draw. If we hit that one more card, we make our flush and they pay us off. Reverse implied odds would be the opposite of that, where if we have a pair with a weak kicker, we make our pair and we feel really good about our top pair of aces, and they have a top pair of aces with a better kicker. Well, we're going to call a bunch of bets when we're the ones behind, and reverse implied odds. If it's we make our hand and then lose money, it's reverse. So next thing is position. So the person who asks last in poker has a major advantage, and this is again going to be a theme across every situation we encounter, pre-flop, post-flop, just like all the way up to the river. Going last is a big deal in a lot of things that we do, because in information advantage, we can see exactly what they did. I mean, the silly example that I don't know if it's exactly equivalent is rock, paper, scissors, where someone goes first. Imagine your opponent tells you, okay, I'm throwing rock. Well, then you just throw paper. And then greater flexibility. This shouldn't be underrated. When we go last, we get to pick, well, do I want to raise their bet? Do I want to fold? We can, if it checks, we can decide whether we want to check again and then see the next card for free, or to bet and apply pressure. And this flexibility is really great and makes it very easy to get money with our good hands as well, because we can apply pressure. We're the ones with options. They don't have options. So then why do we decide to open raise from under the gun? We do this for value primarily. Like the biggest reason is when we open from under the gun, we're playing like 11, 15% of hands. We have a strong hand, and when we have a strong hand, we want to build a pot to make money. A common fallacy you'll see in poker is when people get their pocket aces, they limp and they really don't want to get anyone to fold, so they're not as aggressive. We actually just, it's okay if people fold most of the time. If they fold 70% of the time, 80% of the time, but when they call that 20, 30% of the time, we win way more money than if we would just had not been aggressive at all. We want to be aggressive and build this pot. It's okay if people fold. Point 2 is to thin the field. So back to the people not wanting everyone to fold with pocket aces. It's actually the other way around. When we have a strong hand pre-flop, we want to get as many people to fold as possible, except for like one person or one or two people. And the key point is that if there's 4 people seeing a flop, all that needs to happen is for one of them to get lucky and make 2 pair or a lucky straight to beat our pocket aces. If it's just one-on-one, then our advantage is huge. So yeah, 8 pocket aces I think are pretty much always like at least 80% to win against other hands if just one-on-one. But once you get more and more people involved, our advantage gets cut down to 18% versus like 16% if it was just an average hand. It's just like it's not good to have a bunch of people see the flop with aces. And then factor 3, to sometimes win the blinds. So this is going to be a huge factor as to why we raise later on. From under the gun, it's not as big of a factor. So now we can go over the under the gun open range chart. So again, this is conservative. This is a default. When I first showed this to the other instructors, their reaction was, wait, this is way too tight. I don't agree with this range at all. In practice, a lot of the times we're going to be opening pocket 2s through 6s as well, and we're going to be opening a lot of the suited ace hands, so like ace 2 suited through ace 9 suited would be hands we can add. We also open like king jack offsuit. But I would advise to stick to the conservative default and start to deviate the more comfortable that you get to the more you do in practice, because when you're an amateur getting into poker, everyone makes the mistake of playing way too many hands. And when you get comfortable playing way too many hands, it becomes a bad habit that's hard to shake. You'll just start justifying, oh, I'll play this, might as well. I have bad players, I'll get away with it. And more people in poker have the problem of playing too many hands and playing too little. And when you play too many hands, you lose a lot more money than when you play too few hands. It's a lot easier to be successful if you play a bit too few hands than a bit too many hands. Last point, well, actually several points. This isn't a rigid chart. I wouldn't just memorize this and be like, oh, the box is green, so I'm going to do what the chart tells me to do. We decide to act based on whether the factors of the hand align. So we like pocket sevens because they have a bunch of implied odds because they can make it set. We like Jack 10 suited because it's a very versatile hand that can make straights, flushes, good pairs. We like ace king offsuit solely because its ability to make really good pairs with this good pair potential. So we have to think about the factors and then maybe deviate how we play in line with these factors. Last thing, don't limp, don't do it. Limping is when you just call one big blind. It doesn't have to be from under the gun. I could be in the hijack cutoff button. If I just flat call one big blind, that's a limp and it's really bad. And the reason it's bad, as we can see here, is the hijack raising. We're going to do this in detail more in like I think 2 or 3 lectures from now. I forget which one it ended up being, but when you limp with a good hand, you're not building a pot, you're not thinning the field, you're not stealing the blind. So the 3 reasons we said we want to raise, we're not accomplishing with a limp. When you limp with a bad hand, you're admitting to everybody, I have a bad hand, please bully me. So there's no real way to balance this correctly. The good hands, you're missing out on all the stuff you want. The bad hands, you might want to see a cheap flop with, while you're just asking to get bullied. So it's not good. No computers do it. No top players do it. It sucks. All right. So that gets us into the content for today's lecture. Expected value, equity, pot odds. If you notice, everything that we went over here was all about which hands to raise pre-flop from which position. And we were all talking about under the gun. So you might think, oh, so we did under the gun. So today we're going to do what to raise from the hijack, from the cutoff, from the button, small blind. So we want to do that. We're going to do that next lecture. But we need to understand some key math concepts to make sense of why we start raising certain hands from later positions. Well, the logic is pretty standard, but it's really good to introduce the math now. And some of the math we're going to introduce also is just not like super relevant to this, but we're going to be using it very, very soon within a lecture or two. And we figure if 80% of the lecture is math, why not make the last 20% math? So anyway, let's start with expected value. What is EV? It is the currency of poker decision making. Poker has a ridiculous amount of luck in the short run. I can make a decision that I expect to win 20 bucks on average and lose 100 bucks. So we lost 100 in real money, but we can say, okay, that was a good decision. I got 20 in my expected value. EV is how much money we expect to win in the long run without luck as a factor. And they're considered plus EV if they win us money on average and minus EV if they lose us money on average. So every decision we're trying to maximize EV. So this might seem like, oh, okay, of course, this makes sense. We're trying to make decisions that have the best profit. But what this also means is that then we're okay with taking on a bunch of variants that might lose us money in the short term if it's plus EV. So it could be that it's like basically a coin flip where we have 1% equity and we'll make $5 on average taking this huge bet. And 49% of the time, we're going to lose 200 bucks. So we might lose a whole bunch of money here, but we're okay with that because our expected value is positive. And if we do this coin flip thing 1,000 times, we'll make money. Which takes us to this slide. In the short run, our gain in EV we could have lost money, could have only made a little bit of money, but it broke even. But in the long run, after we get in this exact scenario thousands of times and we play thousands and thousands of hands, we get really close to what we actually should have gotten. We got our EV, our profit starts to approach our EV. So I hope this is mostly makes sense. And now we're going to start talking about some things that actually apply specifically to as you're playing poker, probabilities, that sort of thing. So this concept here is called equity. It's our share of the pot based on how often we expect to be best on the river. it's the probability that we win. But it's all conceptually, I'd like to think about it differently. So quick, let's look at this example on the right here. Pocket aces versus queen suited all in pre-flop. The aces are 82% to win. They have 82% equity. After a bad flop of 2 hearts, all of a sudden the aces have 62% equity versus the 37-ish% equity for the king, queen of hearts. So I don't think it's good to think of equity solely as like probability that you win the hand. I like to think about it as, say there's $100 in the middle. Based on this probability here, 82% of that $100 should belong to us. We're supposed to win 82% of the time, and there's $100 out there that should belong to us. So when we're playing, we're fighting with our opponent. We're trying to realize our equity. We're trying to convert the portion of the pot that should be ours into real money or real opportunity to make money. And if we're bluffing, we're trying to deny, situations where we're trying to deny the portion of the pot that belongs to them, that sort of thing. Last point is that raw equity does not translate to hand strength. So if we put Jack 6 suited all in pre-flop versus 10-9 suited, Jack 6 would be a favorite. Jack 6 would be more likely to win. But then in reality, 10-9 suited is a much easier hand to play, and it will make more money on average because we can make those straights and then get people to call big bets. When we're deciding which hand to play pre-flop, we care which will make us more money in reality, not which would win in some contrived scenario where we go all in immediately and then compare hand strength. So pot odds. Pot odds are the ratio of the pot as it currently stands to our investment to see the next card, and they tell us the equity we need to profitably call. So let's say that I'm facing a bet of like $50, and I do this formula here we're going to talk about, and it says to call this bet, I need 35% equity. What that would mean is that I need to expect to win 35% of the time to call. I need to have 35% equity. So we have a very quick derivation of this formula here. If we're going to call a bet, we want the call to be at least 0 EV. Let P be the money currently in the pot and B the bet we are facing. Then you just kind of do this formula out and you get the probability win has to be at least B over P plus B. Now, this is a like rough and dirty formula to give us a general idea of what we need. Give us conceptually, okay, I need to win X% of the time. But it ignores a lot of nuance. So it ignores implied odds, reverse implied odds, all sorts of things. So it could be, say that we know if we make our flush, our opponent will call on $100 bet. We'll make a bunch of money. And if we don't make our flush, we'll just give up and fold. Well, in that scenario, it might be that pot odds is telling us we shouldn't call, but pot odds isn't factoring in. We'll make $100 when we do make our flush, and we do realize our equity, and we don't lose anything when we're wrong. Yeah, and then because this was when we did this lecture in person, this was pretty confusing. So to make it clear, when we say money in the pot, let's say that the pot was at $10. Our opponent bets $5. That $5 is now dead money. They're never getting it back. So we count it as part of the pot. So if it was $10, they bet $5. It's now $15. So when we're doing the pot odds here, we'd let B be 5 and P be 15. So it would be 5 over 15 plus 5. A mistake a lot of beginners will make is they'll do instead 5 over 10 plus 5, which is totally understandable. I did that a bunch myself. But yeah, we add their bet to the pot, and then we do this formula. So yeah, quick example here. This is what we get. Now, if you notice, the percent of the time that we need to win to call profitably is only 25%. And when you think about that, kind of that sounds strange. Well, when we're calling, we're right, we make 15. When we call and we lose, well, we only lost $5 doing it. So it's okay if we lose the majority of the time. When we bluff in poker, we get called and then we get called, or we call a bet and we were wrong, they had the hand. We naturally get upset and think that we made a mistake. We think, well, I was wrong here. They did have that hand. I shouldn't have called. That's almost never true. We can't think in terms of results where, oh, they had the hand this time, so that means I was wrong. Whenever we do something in poker, pretty much always, we're not expecting it to work more than 50% of the time. A lot of the times, you only need it to work like 20% of the time. I might bluff, expecting my bluff to fail 80% of the time. So our brains want us to be at least winning half the time to do it, but that's just not how poker plays in practice. So here is a table of percentage of pot versus pot odds. So bet size is a percent of pot. So let's say the pot is $10 and someone bets 5 over 10, that's 50%. We just did the math a slide or two ago. That's 25% equity. And so here's the equity for each of these bet sizes. And if you notice, we never need to win 50% of the time to call profitably, ever. The way I think about it is, so if they bet $1,000 and there's $5 in the middle, if we call, we stand to win their 1,000 plus another 5. So we'll at least make double our bet back plus whatever's in the pot. Therefore, we'll never need more than half. And when you play poker, especially like when you're playing at a lower stake, no one uses bet sizes above a pot. As you get to like fancier, higher stakes, people will start to do all sorts of weird stuff where they're betting like 4 times the pot, and it's confusing. But for us, we're almost never going to need to win more than a third of the time. So that's pretty crazy if you like what your brain wants you to think versus reality. And then also, you don't always have to apply this formula on the fly. I'm not, every time someone bets, I don't sit there and go, oh, what are my pot odds? Let me calculate this real quick. I don't even have all of these numbers memorized. Going down this list, I only have a few that I know. I know 100%, like if they bet pot, and that's 33% equity. I know that if they bet half pot, that's 25% equity. And I know that if they bet a quarter pot, that's 16% equity. And then for any bet size in between, I just kind of average it. So let's say that they bet 3/4 pot. I would just say, well, pot odds for that are somewhere between 25 and 33, probably closer to 33-ish. So I'd say that's like 29, 30% pot odds. Yeah. So it's what we said at the beginning of the course, right? Where we're going to need to do some math, but almost everything we can just memorize beforehand to make life easy. Yeah. And if I recall, yeah, we should have fixed this. There's like a small typo on this slide. It was sent to me as a picture, so oh well. But this is kind of going through the math to show that when we bet 37.5 into 50, which is 3/4 pot, we get out that the pot odds are about 30%, or 30% exactly. So that's pot odds, which takes us into draw math. So now we know what percentage of the time we need to win to call profitably. So that leads us into draws, because when we're on a draw, we expect to make our draw some percentage of the time. We're on a flush draw. We want to know, well, pot odds tell me I should be winning 1/3 of the time to call this bet. Am I actually going to win 1/3 of the time, make my flush 1/3 of the time? So we want to be able to get these probabilities. And by the way, an out is a card that completes a draw. So if I have 4 hearts, a 5th heart would be an out. And then we also want to know how to approximate this while we're playing. So it wouldn't be good if we had to do a bunch of math in our head every single time. We just want to be able to go bing, bang, boom, quick. What's my percentage that I win? So a very accurate way to get an estimate of the chances we hit our draw is known as the rule of 4. And what it is if we have n outs and say we're on the flop, so we got the turn and the river left, the probability that we make our draw is 4n%. So if we have a flush draw, which has 9 outs on the flop, the probability we'll make our draw is 4 times 9, 36%. And if we have n outs, the probability we make it on the next card is 2n%. So say we're on the turn, we've only got the river left, and we have 8 outs, the probability we make is 8 times 2, which is 16%. And as for how we come up with this kind of weird arbitrary looking rule, here is the math that gets us to that we're going to use. So if we have n outs, the probability we make our card is n over 47. The probability we make it out on the river is n over 46. And yeah, we can get all these probabilities. And the key thing is we're going to approximate 46 to 47 to 50 to make our math easier. Now, I'm speaking to a camera right now, so you're not going to have to answer the pop quiz question as to why the probability we make our draw is 2n%. I'll answer it for you. If you look at that first green box, the probability we make it on the turn is n over 46. n over 47. The probability of making out in the river in the third green box is n over 46. If we round that to 50 for each time it's about n over 50. N over 50 is 2n over 100, which is 2n%. So yeah. All right, so we're going to start from the fourth green box here. This is our formula for the probability we make our draw on 2 cards, and then we're going to use that to get the rule of 4. So we're starting from this formula. We round everything to 50. Now this term in the middle, the 50 minus n over 50, we can break the 50 out to get this. Now we can expand and then combine like terms. And here's like the real simplification part. So look at that n squared over 2500 term. In Texas Hold'em, you're never going to really ever get a draw above 17 cards. And in practice, the biggest draw you're ever going to see on like any sort of regular base is a 15 card draw. That's if you get an open-ended straight flush draw. Very rare, but it happens. So let's say it's a 17 card draw though. 17 squared is 289. 289 over 2500 is like 1.1%, 1.15% or something. So even in the scenario where n is huge, this term almost does not change our probability estimate at all. So we're just going to ignore it. So we're just going to delete that term to get 2n over 50, 4n over 100, 4n%. And yeah, it's pretty negligible. We don't care about that term. So pop quiz. Lucky you, I'm talking to a camera, so you don't have to do the pop quiz. So let's start counting our outs. First question is how many outs do we have? So 9 to a flush and 8 to a straight. So 17 outs total, right? No. Mistake people will make is they'll overcount. So consider the 5 of spades. The 5 of spades gives us a straight and a flush, gives us a straight flush. So we counted that as a flush out and as a straight out. So we got to subtract that away. Same thing for the 10 of spades. So in reality, we have 15 outs. So by the rule of 4, the probability we make our draw is 4 times 15, which is 60%. So yeah, this is a monster draw. It occurs very rarely, and it's essentially the only draw we're going to see regularly with more than a 50% chance of getting there, of making a straight or a flush. If you notice, it's greater than 50% that we win, that we make our hand. So it can even be higher, right? Because say it goes like 9 of hearts on the turn, 9 of diamonds on the river. Well, now we have 3 9s, and that wasn't accounted for in our math. So here's a situation where we're just going to go bet, 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 because our draw is so likely to hit. Now, this is not one you can solve directly with the rule of 4, but it goes to show that using the math in it, we can solve basically any probability we want to know and find out any likelihood we make our draw. So the first question is how many outs do we have right now? So by my count, we have 1, 2, 3 7s, and 3 aces. That'll give us a full house or 4 of a kind. So 7 outs. Therefore, the probability we make our out on the turn is 7 times 2, which is 14%. Now, let's say we don't make our draw on the turn, which happens 86% of the time. How many more outs do we pick up? Like say the turn comes off of 5. Now, if a 5 comes on the river, we also have another full house. So there's now 3 more 5s that are outs. In general, we're going to have 3 more outs come the turn. So now we have 10 outs. So we make it 20% of the time on the river. So it's 14% plus 86% times 20% equals 31.2%. So again, you're not really going to be doing this in practice, right? But this is one that I just have memorized myself because like you're not going to do the math as you play. I just know it's roughly 1/3. I make a full house or 4 of a kind. But here's comparing the rule of 4 versus the actual probability here. So you can see it's really good for out numbers up through like 12. Even for like a 12 draw, which is a great draw, we're not going to get very often. For a 12 out draw, we're only off by a few for percentage points, and it only really starts to get off at like a 15 card draw, which has 55% equity or 54 in reality. But we don't care because if we have a draw with 54% equity already, 54% to get there, we're just going to be going crazy in betting. We don't say, oh, those few percentage points make or break. And if you notice, we got 31.2 on this slide, and here we're saying it's 33.4%. So that was a little off too. Yeah, the rule is generally great. Just be aware that like for larger percentages, it starts to get less accurate. Larger draws, more outs. That rounding error, that rounding where we took the 46 over 47 to 50, and the part we also deleted n squared over 2500. Those both cause larger errors the more cards that we have in play, so are as outs. So yeah, just keep that in mind. Key takeaway. So flush draws and open-ended straight draws are the strongest draws you'll regularly get in Hold'em, and they still only hit about a third of the time. Open-ended straight draws hit 32% of the time, flush draws hit 36% of the time. And those are the only ones that we're going to see pretty often and that we like to hit. And once we only have the river left, none of these common draws has more than a 1/5 chance of getting there. It's like 16% and 18%. The key takeaway is you'll miss draws much more often than you make them. And a common mistake many players make is chasing, where we call bets that are too large trying to make a draw. You kind of talk yourself into it, but the implied odds, if I make my flush or I make my straight, a lot of times opponents will just completely shut down once the flush gets there. People are so scared of the flush in poker that even if they shouldn't be, they'll just fold and give up when the third spade comes. So we should be willing to say in situations, okay, pot odds disagrees with me, but I'm going to call this bet because I want to hit my flush and make a bunch of money, but it has to be within reason. So pot odds example, let's apply it to draws. Say we have a flush draw and villain bets 10 into 40. Should we call? And here I just want to clarify, this is like confusing terminology that probably going to change going forward. When we say 10 into 40, we mean the pot was 30, villain bets 10. So by our math, pot odds are 10 over 40 plus 10. Draw hits 36% of the time. So yes, we call. If instead the pot had been 40 and villain bet 10, our pot odds are even 16%. So no brainer. But there's a lot of nuance to this decision that we just ignored, which is why we're doing this example. So when we do the rule of 4, it's kind of assumed that when we call this bet, for the price of that bet, we see the turn card and we see the river card for free. Once we pay, we don't have to pay again, but that's not often true, especially against aggro opponents. A lot of times we'll call a bet, and then on the turn, they'll bet again and even bigger. So we a lot of times will only get to see one card for that bet, and the probability we make it in one card is 18%. And here the pot odds are 20, so it's actually saying we shouldn't call if we thought that we'd have to fold in turn versus huge bet. So that's some bit of nuance we just ignored. We might also have a bunch of implied odds where even if the pot odds were crazy against us, we could say we make our flush, they'll call. It could also be the other way around. Villain might plan on folding if the draw gets there. So if you're like, for me, at least all the time, I can tell if my opponent's like an obvious player, oh, they're on a flush draw, I'm just going to fold instantly when the third heart gets there. There are also plenty of players who are just terrified of the flush at all times, and will fold when the flush gets there, even if it makes no sense. So you might have no implied odds. And then the last thing is this whole discussion we're talking about pot odds, and so that we've only said that we can either call or fold. There's a third option to raise. There are lots of situations where it might be better to raise, put pressure, and try to get villain to fold. So that's a whole other option of the tree we haven't even considered that could be great. So yeah, pot odds, again, there's a useful approximation, get us a good idea of what we should be doing or where we're at, but it's not a golden be all end all. I follow this doctrine. I just do what the formula tells me type of thing. Yeah, but for the time being, good baseline. When on a draw, only call a bet if the pot odds are around the probability that we hit our draw. Yeah, we can call when the pot odds are a bit worse, a bit against us. So we could call like a 2/3 pot bet or something on the flop, even if we expect them to bet on the turn with our flush draw. I can do the math, but basically pot odds might say don't call, but in reality, hey, we have a bunch of them. We have implied odds most of the time, so we can give ourselves a few percentage points of leeway. It just is a good justification for why we shouldn't just be calling pot bet with on our flush draw. That's a good way to lose money. So now all those math formulas out of the way. We did pot odds. We did we did the rule of 4 here, rule of 2. A lot of animations make it hard to skip through the slides. So back to open raising. We're gonna do a few more numbers about open raising. I know you guys love numbers. So how often should we be open raising? So we're going to be encountering a lot of statistics in poker, and they're going to be tracked through this thing called a heads up display. I honestly forget if we introduced it last lecture. If not, it'll be in a slide later. But when you're playing on a poker site on the internet, if you're playing against competent and good opponents, they're going to have a heads up display. And what this does is it tracks every hand played at that table and then marks player statistics. And like one of the most important statistics everyone uses is pre-flop raise. It tracks the percentage of the time a player raises when they have the opportunity to do so. So if I was under the gun and I raised, that counts towards my pre-flop raise. If I was under the gun and that I folded, well, that's a hand where I didn't raise and I could have, so that like counts against it. It varies largely by player type. The ideal amount we're aiming for changes. Like we'd want a different pre-flop raise at a 9-handed table or at a 2-handed table than we do at a 6-handed table. Along with position, we raise more from the button under the gun. For our purposes, at 6 max hold'em tables, we should aim for a VPIP of around 19%. And again, it's not an exact science. It can be a few points higher, a few points lower. But if we're running a VPIP of 25, all of a sudden that means we're playing way too many, a PFR of 25, that means you're playing way too many hands and raising. If we have a PFR of 15, that means we're not raising enough hands. Now, how often should we be playing hands? We just talked about raising. Another very important percentage we like to track is VPIP, the voluntary put in pot percentage. So it's a big name for a simple idea. If at any point we put in money that we weren't forced to put in, this hand counts towards your VPIP. So if I call a bet pre-flop, towards my VPIP. If I raise, counts towards my VPIP. Anything like that. So it's hands we put money in voluntarily over total hands played. And we want an average VPIP of around 23%, which means, in just practical terms, we only ever play about 1/5 to 1/4 of our starting hands. And it also means we should be open raising way more than we call. So back here, we said for for VPIP, we want to, for pre-flop raise, we want to be the raiser 19% of the time. And 23% of the time we play hands. So it only leaves 4% for being the one that just calls raises. And we're going to go over calling in, I think, 2 lectures, which hands to call with and why. But this kind of should give you an inkling and an idea that we can call, we'll call in a lot of situations, but we prefer to be the raiser and the aggressor than the one who's calling the bets. So I mentioned this heads up display. The nice part about this being through Zoom and a recording is my slides are finally readable. A lot of times they'll look great on my computer and then I go to present them in class and then it turns out no one can see them. So a heads up display is an on-screen collection of numbers that track those percentages I was talking about it. It's a huge advantage. It's a huge deal. For that HUD Chrome extension, a lot of people have bugs or problems using it. To find it, you just Google Poker Now HUD Chrome extension. It's just, it's the first thing that pops up. And for this course, we're only going to care about 5 statistics, and we've already done 2 of them. And so I'd only set to track those 2 statistics for now, VPIP and pre-flop raiser. If you notice in this picture on the top right, these guys have like 20 statistics. There's some, if you watch some pros, it's actually nuts. Like half of their screen will be boxes with these statistic numbers that they're reading over and over. We're just gonna only use a couple that are really important. And for this one in particular, we can see the 2, 3, 4, 7 in parentheses is the total number of hands played. That 41.6 is the voluntary put in pot percentage, and the 30.8 is the pre-flop raiser stat. All right. Last concepts that are going to be a bigger deal in next coming lectures, fold equity. So we talked about our equity, our pot equity, as just our percentages of the time we win by having the best hand. If we turn the cards over right now and then run the board out, what's the probability that we win that? That's our pot equity. Fold equity is when we win by getting everyone to fold. So the key point is we can't just win by having a good hand. We can win if we get everybody to fold. So when we bluff or we go for a steal, we're betting profitably with low pot equity because our fold equity is so high because we're expecting to get people to fold. As we move to later positions, our fold equity increases. So you'll try to steal the blinds more often, which is just raising with the intention of taking the blinds and nothing else. And yeah, we're going to do the math to justify why the fold equity increases. And that math is done with combined probability. So to approximate the probability of everyone folding, we only need to find the probability that each player folds and multiply them together. So this is rough and dirty math. We're going to assume that each player folding is an independent event. This is, of course, not the case. If there are 4 callers, the 5th person is more likely to call. If the first 3 people don't call, the 4th is less likely to do so. But it's pretty close. So we'll say probability player folds is 88%. Then from under the gun, everyone is going to fold after we raise 52.8% of the time. And from the button, everyone's going to fold 77.4% of the time. So that's like a 25% increase right there, which is pretty big deal, honestly, when we're talking about stealing. If it's 25% as often and like a quarter is off more likely that our plan to steal works, it's enough for us to just raise solely to try to steal the blinds and be sneaky. And then out of this, a question can arise where, say we're in a situation where we're trying to steal the blinds, right? And the small blind and the big blind fold every single time that we raise currently, and we're in the button. They're folding way too often. Should we just start stealing with 7-2 offsuit and any garbage hand? Sometimes yes. In general, I'd say no. And here's why. When you look at the expected value of a play in isolation, we're considering vacuum EV. So maybe if I raise with 7-2 offsuit here, I'll get away with it and I'll steal the blinds. But if I'm raising every single hand, all of a sudden the big blind will realize, hey, wait a second. This is way too much raising. This guy's definitely bullying me. Oh, wait, I think I am folding too much. Let me start calling, or I'm going to raise and put some pressure back on them. So if they are an aware player, and then they adjust to cover their weakness, our greedy strategy is backfired. So we're not winning as much money as we could have been winning if we had been more sneaky about it, more reasonable. That being said, if your opponent just has no clue, then yeah, raise every hand. There's been situations where I'm raising 7-2 offsuit from the button because they just have no clue and they're not reacting to my strategy. So that's it for the lecture. Yeah, for today's playing session, which you don't have because this is on Zoom, I just say I'm gonna do these slides for all the recordings to give you an idea what you should be thinking about after this lecture. Of course, everything that we covered: pot odds, equity, full equity, rule of 4. But specifically, think about when we're going to call a bet. What does pot odds say about our equity? Do we think we actually have that equity? And if not, do we have the implied odds to justify the call that we're making? And this also applies to making bets ourselves. So a lot of beginners, you'll notice, like, we'll bet $2 into pots of 200. I want you to plug that into the pot odds formula and see what you get out. You'll find that you're giving your opponent better than 1% pot odds. So you need to win 1% of the time to justify calling your bet. This leads us to want to bet larger in proportion to the pot. If the pot is $200, we should be betting $100, $150, $200. Yeah, and if the pot's $5, we bet $3. If the pot's $50, you bet $25, something like that. You bet in proportion to the pot. And when people are talking about poker, they talk about half pot bets, quarter pot bets, full pot bets, because that's actually what determines how big the bet is, how big it is relative to the pot. And then you've got this nice how to improve at poker graph, where as you're playing, just think about, hey, I just lost this hand. Why did I lose? What did I do wrong? You identify what you did wrong and then try to find a solution for it. So yeah, that's it. Okay. See you.